Welcome and thank you for joining us for another segment of the Jane Irrigation Training Series. I'm Richard Restuccia, Vice President of Water Management Solutions for Jane. And today we're going to be talking about nitrogen and nitrogen use on farms for crops. Was a very controversial subject a few years ago. When people started talking about regulations of nitrogen, a lot of people started to worry, and we saw a lot of people hitting extremes on opinions. And the thing I like so much about our discussion about nitrogen today is that nitrogen use is really a very scientific subject. How much, what type, and when to use are all part of scientific theory that can be explained. And today we're really fortunate in our part 2 of Fertilizer series to have President of Jane Irrigation, Aric Olson, helping us through this. And I say we're lucky because Aric's got a great education in chemistry, so he really understands chemicals and fertilizers very well. He's got a lifetime in agriculture and irrigation, and more importantly, he's got a real interest, a real curiosity about how all this works together, because he's got a real passion for helping growers increase their yields and be better growers. So we're really fortunate to have Aric with us today. Some of the other things that Aric's done that I appreciate about Aric is, he's been an Irrigation Association board member for many years. He was an IA president back in 2015 when I really got to know Aric. He's a board member of the Irrigation Innovation Consortium, a group that's really making some great headway in technology and the future of irrigation. As you can see, there's lots of other things that Aric volunteers and donates his time to, and that's all really important to our industry, and I really appreciate that. So with that, I'm gonna turn it over to Aric for part 2 of nitrogen. And how you doing today, Aric?
Doing great. Thank you, Richard. And yeah, thanks for the intro, and thank you so much. This is the 49th webinar that you've put on during this COVID period, and you've been doing 2 a week. So I thank you so much for that. It's a huge service to the industry. The topics that you're putting on are very relevant, and the subject matter experts you're bringing on are really good. I really enjoy it. I'm a huge fan, so thank you so much. I know you have a day job. You have to make sales and you have to do marketing, and you're doing this really in your extra time, and it's not easy. And so thank you for that. And I'd also like to say thank you to the people that help you, Richard, the marketing team and the staff. There's a lot of hard work that goes into putting on these webinars, and they really make it easy. And you got a full staff there that's helping you do that. And one of the key team members there is Alan Nazareth. He's a key team member. He's a software developer. He's celebrating his 5th year anniversary with Jane Irrigation today. So congratulations, and thank you, Alan, for those 5 years of service. I remember when you joined us, we had maybe 500 people visiting our website per month, you and Richard. You know, today we're seeing over 60,000 visitors to our website per month, and you've been a big part of that, working on the marketing team under Richard's leadership. So thank you, Alan, and congrats. I wish you another many more years. So I would like to review briefly with one, maybe 2 slides here, the first nitrogen presentation. So I'm going to try to distill that 45-minute presentation down into 2 slides and give you an overview of what we talked about in that. That presentation was really about technology that can help you manage nitrogen. And if you remember, or you know, that nitrogen is super complex. There's a chemistry involved. Nitrogen can take so many forms, from the nitrogen gas in the air to the different forms of nitrogen that are used by crops. We do have amazing technologies to manage nitrogen. You remember the satellite imagery that we talked about, and this CC chloroform index is satellite imagery to help tell you how much nitrogen is in the plant's leaves. We use soil moisture sensors to look at infiltration rate to make sure that water's not moving past the root zone, because nitrogen will dissolve in water and move with the water. And if you push water past the root zone, you're putting water, potentially all the way down to the groundwater. And so that graph on the left there shows an EC profile where I can look at, fertilizers or salts moving through the soil. So those are a couple technologies. We shared technologies about in-field testing for soil moisture and then ways to apply nitrogen more efficiently with irrigation. And then the picture on the upper right shows that, if we don't get this right, what can happen? That nitrates and phosphates can either go to the groundwater or go to the bays or the coastal areas. You get runoff, and then you get that eutrophication that can happen. And so we really have a delicate balance. We need nitrogen to grow crops to feed the world. There's technologies that can help us apply the right amount at the right time. We concluded that presentation talking about the 4 R's, and the 4 R's are, use the right source of nitrogen, get the timing of the application right because it moves with water through the soil, put the right rate or application on, and put the nitrogen in the right place where the plant can use it. Those are the 4 R's, and those are critical, and I think as we go through this presentation, please think about that. And then we're an irrigation company, so I want to have a huge plug for irrigation. Poor irrigation will lead to poor nitrogen use efficiency, and this is really, we're going to talk more about this in this presentation, and it can lead to significant impacts on the environment. Here's another second review slide. I just wanted to show the complexity that we're dealing with in the nitrogen cycle, that we have nitrogen all around us. It's 78% of the air we breathe is nitrogen. That nitrogen can be fixated by legumes, alfalfa, soybeans can create nitrates in the soils that can be used by other crops. But we have this continuous loop of a cycle that takes place through different environmental conditions of the soil in terms of temperature and humidity, and then there's different tools that have this symbiosis that happens where things convert back and forth from either nitrate or ammonium. And if you recall from that last presentation that the plants can really uptake nitrate and ammonium only, and so you want to get the fertilizer into the nitrate form. That's what the crop can use. The crops can use some of the ammonium also, and there's a bunch of reactions there. So it is complex. You have to have the right conditions. If it's too hot, too dry, too wet, you're going to lose nitrogen to the environment. It's either going to go up in the air, or could go stuck in the soil, or can go to the groundwater.
Eric, we've got a question here, and I want to remind everybody that you can type in your questions into the Q&A or into the chat, and I'll work those into the discussion this afternoon, and you can find those buttons towards the bottom of your screen if you move your cursor over to highlight. But we have a question here, and you've talked about poor irrigation can lead to poor nitrogen use, and this term nitrogen use efficiency. What does that really mean, and how do the two interact?
Yeah, nitrogen use efficiency is the nitrogen that's effectively used by the crop as a fraction of the total applied nitrogen in that cropping system. So again, the amount that's used by the plant or crop divided by the total amount of applied nitrogen. And, this was, they really spent time in studying this. That there was a study by FAO in 2002 that showed that nitrogen use efficiency on cereal crops was 31% average on worldwide, meaning that almost 70% of the nitrogen we use on cereal crops was not in a beneficial use to the crop, meaning that it could go, in the groundwater, it could be runoff, it could be stuck in the soils. So that's a lot of waste, right, when you think about that 70% waste. And more recently, the study was updated in 2015. Now, we've made a lot of improvements, but still globally, we're at 35% nitrogen use efficiency on cereal crops. In the U.S., we're over 41% by that study, and in many cases, I'm sure over 50 or 60%. But let's just say we're 60% nitrogen use efficient on cereal crops in the USA. That still means 40% is not beneficially used. And you know, from this nitrogen cycle, you can see where that goes. It either can go, you know, down into the soil, into the water. It can do runoff, or we can get that denitrification where we're creating nitrous oxide down there on the bottom of the table. Those are all the deleterious effects and where this waste occurs. So we're going to talk about that waste a little bit more and how do we minimize that? How do we get better crop uptake? And it's really part of this title of the slide. How much to put on, what type, and when to apply will help you minimize those significant losses that we have.
Right, so I mean, nitrogen costs money, right? And all the growers I know are really good business people. So I know they don't want to waste money, right? Because that's really what they're doing. So, so this is just caused because they're not really taking into account some of these, some of the 4Rs.
That's correct, and I would say, look, it is not easy. It's super complex, and you know, we're going to talk about these three key areas about how much to apply, when to apply it, you know, and that will give some insight. But you know, just going through, there's so many variables. And one of the slides here that I'll show all the variables that you're dealing with, and if you're off a little bit, this is where you lose this nitrogen efficiency. So let's get into it and say, well, how much nitrogen are we even talking about here? You know, and I have a couple of crops near and dear to my heart. I like field corn and I like almonds, so we're going to use some examples. And so when you think about growing these different crops, you have to have a goal in mind. What yield are you going after? What kind of levels of profit and costs are you willing to incur? And what level of risks are you willing to take? This, you know, you kind of have to start out there with a game plan. And once you know you're growing corn, field corn, or almonds, or whatever crop it is, the best way to get some idea on the amount of nitrogen to apply is to go to the university in your area, the local extension department, or Department of Food and Ag, or industry associations. They'll give you real good insight on, you're going to grow field corn in Iowa. Go to the Iowa State website and you type in field corn, how much nitrogen, and they'll give you a really good model for your area, your soil type, your conditions, about how much to apply, what to apply, and when to apply. So if you research that, you'll see that. So that's where I would start. You have to think about the application techniques and the timing. The timing is critical. We'll get into that. But what mechanisms do you have to apply nitrogen? Are you putting it through the irrigation system? Do you do in-field spraying? Do you are you running it through center pivot? How are you applying the nitrogen? Do you just knife it in as a starter fertilizer at the beginning of the season? This application technique and cultural practice is critical when you think about the amount and the timing and when. Water has a significant amount of nitrates in it already. And that can be a significant source of nitrogen for your crops, and we'll do a sample calculation on that. And then you obviously have soil and crop residuals in the previous crop. You know, if you have a cover crop, say, that creates nitrogen. Remember the nitrogen fixation either through, say, alfalfa, which fixates a lot of nitrogen, or soybeans. So if you have a corn-soybean rotation, you're going to get free nitrogen, really, from the fixation that these plants actually do for you. So these all go into help calculating how much nitrogen to apply. Before we do that, though, I'd like to, look at a nitrogen or a fertilizer label. This is, I think, important for us to, understand, and all of us maybe are gardening or can go to the local garden store and pick up a general purpose fertilizer, and you see these three numbers, 20, 10, 20, and you figure out, well, what does that mean? I think we all know that probably means nitrogen, phosphorus, and potassium. But what does it mean? At 20 units or 20%? Or this is always the challenge. And then you look at this fine print on those labels, and it becomes even more confusing. And I just wanted to simplify this for you. There's a few key things that matter here. Those three numbers, it's always nitrogen first, then the potassium, and then phosphorus, then the potassium, and those numbers are expressed in percent. So 20 means 20% or 0.2, and 10 means 10%. So in this case, if we had a 100-pound bag, we'd multiply it by 0.2. there's 20 pounds of nitrogen in a 100-pound bag. There's 10 pounds of phosphate in this, and then there's 20 pounds of pure potash in this bag. You can see there's some very small micronutrients that you can read there, very small percentage. So I always wonder how they measure that low, but that's pretty interesting. But that's what the general label looks like, and this is a general purpose fertilizer.
So Aric, the 20, 10, 20 just adds up to 50%. What's the other 50%? Some of those micronutrients, but what else is in there?
Yeah, that's interesting, right? So, and you would always think like, gosh, that's a low percentage of nitrate and I want high nitrate. So why don't I just buy urea with 46%? Should I do that? And then there's a lot of questions that come from these labels. So, 50% is fertilizer that you need here. And then the other remaining 50% is typically some form of carbon, hydrogen, oxygen. It can be sand or granular lime, peat moss, or even sterile dirt. It could be in this remaining 50%. So it's always good to read kind of the fine print and see what else is going on in that remaining 50%.
Yeah.
Okay, so a specific example, let's say we're growing field corn in the Midwest, and these numbers are close to home for me, and I want a target yield of 230 bushels an acre, non-irrigated land in the Midwest, maybe on the Minnesota-Iowa border, and we're following soybeans. So with soybeans, I'm going to get some credits. I might get 20 to 40 pounds of acres credits from running soybeans. I also have a beef cattle farm, and I have to have manure from that beef cattle farm, and I'm going to get some manure credits there. And that's a little bit more tricky because the manure, if it doesn't have the right temperature, humidity, moisture, microbial environment, you may or may not have as much nitrogen as you think you do. And so that's a challenge to get. But we're going to get some credits. We'll go to Iowa State's website. They got a great calculator, and we're going to look at that. Extension University. We're going to plug in these details on soil and the credits and my target yield and cost, and they're going to tell me put on 200 pounds of acres per acre of nitrogen. And they'll give you a range. They'll say maybe 185 to 215. They'll do something like that. So now I have the amount. I know I want 200 pounds. I got to get applied. And you got to start thinking about, well, what should I apply? And that's a bigger question. So for farmers in the Midwest, you might apply anhydrous ammonia, which is 82% nitrogen. So that's good. Like we were talking about that earlier example. But that's under pressure liquid, and you got to kind of knife that in. And so the calculation and how it works out is you have 200 pounds that you want to apply, and you're applying that 82%, so you divide by 0.82, and you actually have to apply then 243 pounds of anhydrous ammonia per acre. That gives you the amount there. And, if I chose, well, I didn't want to deal with that pressurized gas turning into a liquid, or I felt that it's a little dangerous, let's use 46% nitrogen urea. And then I do that same calculation, and I have to apply 435 pounds. Urea has its own challenges there. So, and then you say, well, what's the cost difference? There's a lot of questions that go in this. Anhydrous ammonia is going to be the lowest cost. Urea is going to be, could be quite a bit higher. And then, what happens in the soil and when does the crop needs it? These are further questions you have here. But let's just start with a simple calculation, right? I need 200 pounds, and then here's how I apply it. For my friends on the West Coast, looking at almonds, and say also I have a similar set my target, and I want 3,000 pounds of almond per acre, and I got some givens here. I got a drip irrigation set up, and I'm putting 48 inches of water per year. My irrigation system DU is 0.85. You can see the soil type. I have no cover crop. My well water contains 7 parts per million nitrates. The U.S. standard for drinking water is 10 parts per million nitrate nitrogen. So this is a little less, this would be okay for drinking water. And by doing the calculation here, 7 parts per million nitrate nitrogen times 48 inches times this conversion factor, 0.23, my water for this crop is going to give me nearly 80 pounds per acre. So you remember the corn example, I needed, 200 pounds. Wow, I'm getting 80 pounds just from the irrigation water. That seems a lot, and I think people don't realize that. So again, I go to the local extension and say I'm growing almonds. The best place to go is probably UC Davis. They've come up with a model that says if I want 1,000 pounds of kernels, I'm going to need 68 pounds an acre. So I'm growing 3,000 pounds. I multiply that by 3. So I need 204 pounds of nitrogen per acre. Now, I'm going to apply that water, obviously, through my drip system, and I'm going to fertigate, right? I'm putting the nitrogen through my fertilizer system, most likely, in this case. And so if I got 80 pounds per acre from the water, I need another 130 pounds more that I'm going to have to apply. Now, I have a uniformity of my irrigation system at 0.85 DU. So I divide by 0.85 the DU, and it tells me that I have to apply 240 pounds. So I really have 240 minus 80 pounds. That's what I'm going to need to apply in addition to the fertilizer. But let's just say, pretending I didn't have any nitrates in the water, which is not really true, you can say, well, common fertilizers in California are UAN or urea ammonium nitrate, 32%. So you can see the pounds times 0.32. I need to put 750 pounds of that on, or if I chose to go with a CAN 17, calcium ammonium nitrate, that's a 0.17 times. I have to put on a lot more pounds. Now the price will be different, and typically these are priced out, the way you look at it is it like a unit of nitrogen and how much. Now you're getting a different profile with calcium in there versus urea in these combos. And so that's another thing that we need to look at. But this gives you some idea of, again, how much nitrogen to apply, that if you're applying irrigation water, that's a huge source of it. If you have a cover crop or you got certain soils, you're going to get some benefit. If you have a crop rotation, you're going to get benefit. All these will go into the calculations of, this calculation says I need 240 pounds of N per acre for this crop to get that, targeted yield. You get some idea of all the sources, and you can calculate all those up.
So Aric, if I take my time, right, and I go through these calculations, but I want to get, some extra input, extension agents, these guys really, people like that, should be on my speed dial, right?
I would definitely, they should be your friends. I mean, there's so many variables here. The calculations they're not easy, and as we get into the presentation, the complexity you'll see gets higher. But there's a lot of people that can help. There's we have in our company certified crop advisors in our company that can help you. Our irrigation dealers, your PCAs, the extension agents. There's a lot of help out there, and with the internet, it's easy to find it.
And I want to ask you about these nitrogen credits too, and just the magnitude of those, right? I'm not quite sure I fully understand that.
Yeah, so when you're growing soybeans or alfalfa, again, that's taking nitrogen out of the air and fixating it and making nitrogen near the roots of the crop. That nitrogen is then in a form that can be used the following season. So you've fixed nitrogen in the soil for next season's crop. If you have a cover crop, that can also create that. So those are the credits, and it's kind of well modeled on what cover crop or which type of legume will create how much nitrogen credits that you get. The irrigation water is pretty easy. The soil's a little more challenging. You can imagine a sandy soil is not going to hang on to anything. If you got a clay soil with a good cation exchange, this can hold on to nitrogen better, so you're going to get a little bit better deal there. So some ideas of credits, where they come from. Now, nitrogen's interesting, and for the most part, the more nitrogen you apply, in general, there's a trend for increasing yield, but that's not the whole story. As we saw from the last presentation, nitrogen's one piece of the story. There's soil type, irrigation, There's crop plant material and genetics that go into creating a yield. There's weather obviously as well. And so the universities, and this is and there's many companies that have this, they'll give you an optimal return on investment for your nitrogen investment. And this, on the left side of the graph, is return to nitrogen dollars per acre. And at the bottom there, it's the nitrogen rate in pounds of nitrogen per acre. So the green line is going up. That's fertilizer cost. So if you add more pounds per acre, you can see it's a linear calculation of cost going up. The blue line is if I add more nitrogen, the yield's going to go up. But you can see as you get further to the right, that blue line flattens out, and the return, the gross return, you're limited. There's a yield potential maximum of this field, whatever crop that is. And so simply applying more nitrogen does not really marginally help you. And there is an optimum then for your optimized net return, or MRTN, maximized return to nitrogen dollar, and it gives you a pretty good range. It'll say 131 pounds an acre to 125, and this is maybe up to 140. That's the range that you can apply. Again, remember, because you got a lot of variables, but this is the optimized for the nitrogen expense. And things are so tight running these large commodities that you really have to manage nitrogen very tightly this way. So now that we've answered the question how much to apply and where to go and some of the calculations, probably the more daunting question is, well, what type of nitrogen should I apply? If we're simply gardening at home, we go to the store and we look on the shelf and, we want a complete fertilizer. We want one box that has everything we need in it, right? And that's what's called a complete fertilizer, and you'll see 888, 5, 15, 5, and that's 8%, 8%, 8%, or 5%, 15, 5. And these are typically formulated for certain, plants that you're growing, and we see those in the store. But those are pretty expensive. Those blends and those coatings and those slow releases, those are going to be a lot of money. That might, I didn't calculate that out, Richard. You probably know this, a couple bucks a pound, whereas, the commodity fertilizers, for amount of nitrogen, is going to be maybe 25 or 30 cents a pound. So it's a huge difference, and you just couldn't apply these complete fertilizers and be in business very long. In the West, for permanent crop folks, there's a lot of CAN 17, which we've already talked about, and UAN 32, and then ammonium nitrate 20. So again, that's 20% nitrogen. Those are popular. In the Midwest, anhydrous ammonia, you're growing a lot more of the field crops. That's the lowest cost, and you get 82% in, but you got to knife that in, and it's sometimes maybe a little trickier to handle. And urea 46 is very, very popular. So these are some of the more popular ones. And obviously manure is can give you some credits as well. So these are the popular fertilizers, so you could kind of start there, but I would also get help. And when you go to get help on what kind to apply, you're going to need to be ready to answer all these questions. Are you irrigating? What's your irrigation system? Is it water soluble? Do you have a spray system? Can you spray in season? You have the ability to knife it in. When do you plant? How do you plant? Do you have manure? What's the condition of the manure? Is it hot and dry where you are? Hot, dry, windy, or is the manure moist? What's the ppm concentrate of nitrogen in your irrigation water? The soil condition, texture, soil pH. A lot of these nitrate fertilizers will lower the pH of your soil, making it acidic. When you get too acidic, then other deleterious effects can happen. So soil pH and managing pH is absolutely critical for growing these crops. And then you have to think, what are your cultural practices? What kind of equipment do you have? Do you want to blend these nitrates that we're talking, nitrogens, with maybe a phosphorus or potassium? So these are all the things that you need to talk about with the person that's helping you recommend the fertilizer plan. And then you have to think about application efficiency. There's a reason why that nitrogen use efficiency is so low globally when you think about it. And it means we're broadcasting fertilizer, we're broadcasting too much of it sometimes, and we're not getting the timing right, and then deleterious effects are happening. On irrigation, we're irrigation professionals, so we might say, you know, an almond orchard that's been in use for 10 years might have a distribution uniformity of say 0.85. That you're already losing efficiencies for fertilizer applications, right? So think about then, if you don't get the timing right or the right fertilizer, or you have volatilization, the best you're ever going to be able to do if you were perfect on fertigating would be a 0.85, the exact match of the irrigation system. But that's simply not possible. So your fertigation application efficiency may be 0.7 at best, meaning you could be losing 30+% of your nitrogen investment. So those are all the questions. You know, you can start with some of the common, but get help on these questions and find out what they mean in terms of credits. You know, you can, see. Now, one big challenge, though, is, like, we spent a part of this presentation talking about nitrogen. Now, if that's one part of it, you need phosphorus and potassium, and you need micronutrients. And you want to make sure that when you're applying your nitrogen fertilizer, it's compatible with your phosphorus and your potassium and micronutrients, that you don't cause issues. And there's serious and severe consequences if you don't pay attention to that. If you just go and ask for the cheapest nitrogen you can give and the cheapest phosphate you can get, and you run it through your drip system, you may have a serious problem. And you know, I just want people to know and understand this is a compatibility matrix, and this is from the Yara company, but most fertilizer companies have it, or distribution companies have it. And how you read it is that the ammonium nitrate is on that first column, and you walk down the column and you say, well, I'm going to run ammonium nitrate, and if I go to the very bottom there, I'm also going to put elemental sulfur on my field. And then I can say, well, what happens? And then I see the number 7 there, and I see red showing elemental sulfur is incompatible with, did I lose you?
Yeah, we lost the PowerPoint. We can still hear you though, Aric.
Okay. The elemental sulfur is not compatible, and it says it's red, and so it's dangerous, right? So let's see if I can get back on here.
So Aric, when it means it's dangerous, does it mean it's literally dangerous to people, or that there's volatile, it's volatile? What's that danger mean?
Well, in this case, elemental sulfur is combustible, and it can react with ammonium nitrate. So that's what the red is, and they'll give you a whole list. You see a red 7, they'll give you a definition. So they'll basically say any 7 here is actually combustible, and we've seen some pretty severe accidents with that. So the red is going to be, it's kind of some explosion risk or combustible. The yellows are mostly, when you combine them, there might be some explosive risk, but it might be, they absorb moisture and they make caking, and then there's some reaction that happens. Obviously, if you're running it in a drip system, you don't want anything that will plug up. So the best thing to do is take your liquid fertilizers, put them in a jar, and see, stir them up, and then see what happens overnight. And if they precipitate out, you got a little bit of a problem.
That's kind of that's the way I can test it ahead of time then, right? Just put it in the jar and.
Correct, yes. Richard, you can see my screen, right? Is that working now?
Yeah, we can see your screen. It's not in the presentation mode right now. We can see the next slide too, but that's great. That's fine.
Okay, yeah, sorry about that. I had the train went by and I moved my.
Yeah, the 11:35 was right on time, right?
Always the joys here. Okay, so when do we want to apply this nitrogen is kind of the key next question. And from you can see this now?
Yeah.
Sorry, I'm moving around. Okay. So the crop uptake of nitrogen, it's very similar for most crops. It's kind of this S-curve. And you get a very little uptake initially in the early stages, followed by a very rapid uptake in the kind of the middle 1/3 to 2/3 of the growing season, and then it kind of flattens out towards harvest. And you can kind of see that. So it's important. You remember, if you put down nitrogen, it's somewhat volatile. It can volatile off through the air. If you get a rain or an irrigation event, the water can push it past the root zone. So getting the nitrogen down right ahead of time, right before it's used, is super critical. And you can see when the uptakes are on the left here, and for that corn crop, you can see most of the uptakes happening in mid-June to early August is when most of that rapid growth and most of the nitrogen, 2/3 or more of that nitrogen uptake is occurring. In almonds, you have from early April all the way into late July when 80% of that nitrogen is utilized. So from early April to later July, early August, right before hull split, you got 85% of the nitrogen being utilized there, and a big chunk of it is at that that spur leaf expansion. It's a 1/3. So you better have your nitrogen in the ground at the root level at that timing. Otherwise, again, you're wasting, right? You're not able to utilize it.
So Aric, we've got a question here from a viewer, and he's already using drip, but he's got some really sandy soil, and he's worried that the nitrogen's just leaching past. Are there some irrigation techniques or things he can do to help stop that or slow that leaching?
Probably the best thing to do is, look at soil moisture and have a profile probe, and do your best to look at an infiltration rate, and make sure, if you know where the roots are, say, if it's a permanent crop and the roots are at 24 to 36 inches, and you're going to want to, make sure that you're not pushing water past that root zone on these irrigation events, and then, that will help you. That's probably the best way. And then you can also, if you have a soil moisture probe if you have a EC, you can monitor where the nitrates are going. So not only can you see the water where it's getting to, but you can see where the nitrates and fertilizer is getting to or going past. If you're pushing that fertilizer past the root zone, you'll see it on the EC monitoring of that.
Yeah, great suggestion. That'll be very helpful. Thanks.
Okay, so in summary, again, another presentation on how this complex the nitrogen process is, and if I can just, I'd say get help from a CCA, University Extension, fertilizer supplier, irrigation dealer. They're all there to help, and we want growers to do a great job, get great yields and returns, and do it in a manner that's good for the environment. There is this technology that I talked about from also last time. And hopefully I pressed upon you let's get the right source, the right rate. We talked about the pounds and then the time, and then put it in the right place, right? You don't want to bury nitrates, say, 6 feet deep if your root zone is at 3 feet, right? So that's the right place. And then, if you have a poor irrigation system with a distribution uniformity of, say, 0.5, remember, you're not going to be able to do better than 0.5 on the nitrogen. It's going to be worse because of the challenges of holding the nitrogen in the proper form for the crop to be used. So if you've got a 0.5 DU on water, you might get a 0.3 on fertilizer because it's just challenging. So even if you got a 0.7 DU on irrigation, and the fertilizer efficiency can be 0.5. So you're going to have a lot of inefficiencies and a lot of waste. That's a lot of money. There is some environmental impact, and you're wasting this money here. I would also, some great references that I've used over time and I've studied. I've taken a couple classes from Dr. Burt. He wrote a book with Chris O'Connor and Thomas Rohr called Fertigation. That's a phenomenal book. shows you how to do all these calculations in a really nice detail, not overly complex. Really anyone can follow that. So that's a really good job, really good book there. And also for out west here, this Western Fertilizer Handbook, that's also a tremendous resource, along with, you know, the internet has, you know, a lot of tools to be able to help you. So with that, I want to say thank you, Richard. Thank you for having this and enjoyed talking about it. I want to remind you my email's on there if you have any questions for me, and I'll let you have it, Richard.
Yeah, thanks, Aric. Great presentation. You know, when we first started talking about this presentation a while back, I thought I had a pretty good handle on nitrogen, and I quickly learned that I didn't. But one thing that I do appreciate about this is that you helped all of us be better at our nitrogen use and figuring this out. And I think everybody's going to be able to raise their nitrogen use efficiency levels as a result of this. So thank you. Great presentation. And I also want to say Friday we're going to be back at noontime, and we've got Lance Sweeney, irrigation designer that's known worldwide. He's done work all throughout the world. And he's going to be talking about using stormwater for landscape irrigation. That's this Friday at noon. It's it seems like kind of a dry subject, but it's quite an entertaining presentation. I think everybody will enjoy that. Thank you to all our viewers for spending another lunch hour with us. We really appreciate your time, and we're really committed to making this good content for you so that this is a good use of your time. So again, if you have any recommendations for subject matter or suggestions for us in general, you know, we send you that follow-up email this afternoon with the recording. Please feel free to shoot me a message back when you get that and let me know. So again, Aric, thank you. Thank you to all our viewers, and hope we see a lot of you back on Friday for our session with Lance Sweeney. All right, thanks very much, everybody.
Thank you. Bye-bye.